Probability. Probability is a very deep topic. Whole books are written on probability. Whole courses are taught on probability. For the purposes of an introductory statistics course, we're going to be dealing with probability in very simple terms. I'm going to flip this coin. Now, what are the chances that we have a heads from that coin flip? I'm sure intuitively you know and can easily say 50%. But why? Why do you know that's 50%? Well, what you've calculated intuitively is the likelihood of the desired outcome given the total number of possible outcomes. On a coin, there's only two possible outcomes, heads or tails, and there's only one desired outcome, heads, right? So it's 1 divided by 2, which is 50%. Tails. All right, so in order to calculate probability, you have to know two things. You have to know first the total number of desired outcomes, and you have to know the total number of possible outcomes. Right? All right. Now let's use another example to make this a little bit clearer. Let's say you have a deck of 52 cards, right? And we want to know the probability associated with drawing a jack. Interesting. So the desired outcome is a jack. It could be a jack of hearts, a jack of spades, a jack of clubs, or a jack of diamonds. A jack, right? So what is the total number of desired outcomes? Any jack in the deck? There are 4 of them. And what's the total number of possible outcomes? Well, you could draw any one of those 52 cards, only 4 of which would be jacks. So that's 52. And if you do that calculation, you find that the probability of drawing a jack using a method that ensures random selection is 0.077. Okay, now let's look at another example. Let's say you're working with a group of 310 children, right? Okay, now of these 310 children, 170 of the kids are girls, and that means that 140 of the children are boys. Now, if you use a method that ensures random selection, what is the probability that you will draw a girl from this group of 310 children? Well, what's the total number of desired outcomes? The total possible desired outcomes is 170, right? Because there's 170 girls in this group of children. What's the total number of possible outcomes? Well, you could draw any one of the 310 children. If you do that calculation, you find that the probability of selecting a girl from this population of 310 children is 0.55, right? Now, when we talk about probability, you're going to find, as we've discussed before, that probability, proportion, and percentage all refer to the same number, right? So the probability that you will draw a girl from this group of children is 0.55. The proportion of times that you will draw a girl from this population is 0.55. And the percentage of times that you will draw a girl from this population is 55%. So in order to calculate probability, you must know two things. You must know the total number of desired outcomes, and you must know the total number of possible outcomes.